In this video, we evaluate this UC Berkeley Integration B question. This appeared in the 2025 qualifying round. So we can start off by doing a U sub, right? So this one, we can let the denominator, let me start with a different color. We can let the denominator, that is this one, equal to a certain variable, that is y. So y to be equal to the denominator of the integrand, that is square root of 1 plus the square root of x minus the square root of 1 minus the square root of x. In this one, let's find the change in limits. When x is equal to 0, that is the lower limit, we have y to be equal to the square root of 1 plus the square root of 0 is 0 minus the square root of 1 minus the square root of 0 is 0, and that is 1 minus 1, that is equal to 0. When x is equals to 1, that is the upper limit, we have y to be equal to the square root of 1 plus the square root of 1 is 1 minus the square root of 1 minus the square root of 1 is 1, and that is really equal to the square root of 2, right? So y will change from 0 to the square root of 2. Now let's find an expression for dx in terms of dy, shall we? So we can square both sides of this substitution, right? So we are going to square both sides of that. So that is y squared is equals to the square of this guy. That is the square root of x minus 1 minus the square root of x. And I'm going to square this to maintain equality, right? Now we are going to find an expression for x in terms of y. So this is y squared on the left hand side is equals to, foiling this is going to be the square of this. And that is 1 plus the square of x plus the square of this. That is going to be 1 minus the square root of x, then minus 2 times this and that. So that is going to be 2 times the square root of 1 plus the square root of x, which is multiplied by the square root of 1 minus the square root of x, like this. So this is how we can square that. So y squared is equals to, this cancels that. 1 plus 1 is 2 minus 2 into, we are multiplying these guys and they are difference of 2 squares. So that is just the square of the first one, which is 1 minus the square of the second one. Square of root x is x. Then this one is under the square root. Mustn't forget. So y squared is going to be what really? So this one, I'm going to bring 2 square root of 1 minus x to the left hand side, and the right hand side becomes 2 minus y squared. I'm trying to isolate x here. So this divided this one by 2, divide by 2. This cancels, and the square root of 1 minus x is going to be equal to this 2 minus y squared all over 2. Can square both sides to take away the square root. So this cancels that, and I left with 1 minus x to be equal to 2 minus y squared all over 2. All this 1 squared. Then isolating x, x is going to be equal to 1 minus this guy, 2 minus y squared all over 2. All this 1 squared. So this is an expression for dx, for x in terms of y. Now let's find an expression for dx in terms of dy. So differentiating this one with respect to y, this is a constant surely that differentiates to 0. Then this one that becomes negative 2 into 2 minus y squared all over 2. Then you differentiate what is inside the parenthesis, then you multiply by that. So inside the parenthesis, differentiating that is going to be negative 2y all over 2. That is how we can differentiate that. That's the chain rule. So dx is going to be, this will cancel that, and this will cancel this. And then we have negative, negative, that becomes positive, right? So in the end, we just have 2 minus y squared multiplied by y dy. So this one is an expression for dx in terms of y that we can plug into our integral. That is here. Now we can take our integral from the x world into the y world. Let's do that. So I is going to be equal to what? The integral. Now in the y world, the limits of y are from 0 to the square root of 2. 0 to the square root of 2 of 1 all over y. The whole of this is y from our substitution. So this is y multiplied by dx. We found an expression for dx at the bottom. You can just go and pick it up. So this is 2 minus y squared times y dy. So this is 2 minus y squared times y dy. So the integral is now very easy. So integral from 0 to the square root of 2 of y cancels y here. Now you're left with 2 minus y squared dy. Okay, so this one is now integrating. This is 2y minus 1/3 y to the third. Then the limits of integration from 0 to the square root of 2. So I is going to be plugging in your upper limit. This is 2 root 2 minus 1/3 root of 2 to the third. This is the upper limit. The lower limit is really 0 because we plug in 0 here. That gives you 0. So I is going to be 2 root 2 minus 1/3. Root 2 to the third is root of 2 times root of 2 times root of 2, which is 2 root of 2. So this one is what? You can factorize root 2 out. Yeah, left with 2 minus 2 over 3. 2 minus 2 over 3 is 6 minus 2 over 3, which is 4 over 3. So in the end, you have 4 over 3 root of 2. So this one is the answer to our integral. So I avails to 4 over 3, the square root of 2. So if you go back up, this integral, this UC Berkeley integration B question, the 2025 qualifying round, this one evaluates to square root of 2 over 3 times 4 square root of 2 over 3. And this agrees with the answer that MIT gave. So this is how to solve this kind of integrals. If you have an integral that looks a bit complicated, you can just let y to be equal to the denominator, try to find an expression for the x in terms of the new variable, and then the integral will become very easy for you to integrate, and that is from here. So this is how I can solve it. If you know an easier way of solving this, please leave a comment in the comment section and let me know what you think. Anyway, that's it. I thank you so much for watching this video. Please subscribe to my channel for more of this content. I will see you in the next one. Bye bye.